Good morning, students. As you see the diagram, I know you all will be afraid. Very important topic, the volume and pressure changes during cardiac cycle. At the same time, you also think that this is such a difficult topic, how to know all these curves, waves, pressures, volumes, all those things. The main purpose of this video is to clarify all those doubts, and at the end of this video, you will come to a conclusion that, oh, such simple is this topic. It is a very important topic and it is very easy to understand also. So as I mentioned, at the end of this video, you will be able to decode each and every curve of this Wigger's diagram. So this is the Wigger's diagram, which includes pressure and volume changes during cardiac cycle. So before going into this diagram, in my previous video, I have clearly explained about atrial ventricular changes during the cardiac cycle. So I have to again refresh that. If you have not watched that video, I will send the link in my description, the first part of cardiac cycle video, so that you can watch it. Anyway, I am going to describe it here also, so that I can compare each and every phase of the cardiac cycle in this diagram, which will make you very easy and make you understand. Now let me go to the cardiac events. I am going to explain the events which I already discussed in previous video, but I want to compare these events with this Wigger's diagram or the pressure and volume changes curve. This one, you students face very much difficulty in understanding this concept because you are not linking this exact event with this, and you are fixing in mind that this is difficult. That's why you are not able to decode. So now I will make it as simple as possible, and I also want you to mention in the comment section after watching this video how useful it was for you. Duration of cardiac cycle is 8.8 second, which you all know, and it is divided into 0.3, 0.5 second regarding ventricle. So ventricular systole is just concentrate, duration of cardiac cycle is 0.8 second, no doubt in that. And in that ventricular systole is 0.3 second, ventricular diastole is 0.5 second. Again you concentrate in this diagram, exactly I have drawn from 0 to 0.8 seconds. So this is the cardiac cycle duration, and see the red color here, which is 0.3 second. As I mentioned, the ventricular systole is 0.3 second, and ventricular diastole, which I have drawn in green color, is 0.5 second. This is how much? Yes, 0.4. This 0.4 second is diastole, and this is how much? 0.1, 0 to 0.1. This 0.1 second is also diastole. So green color contributes 0.5 second, which is diastole, no doubt in that. Just here, ventricular. I am here mentioning about ventricle. So ventricular diastole total, and this should be actually 0.4, sorry. Yeah, this is 0.4 and this is 0.1. Yeah, totals here. Diastole is 0.4 plus 0.1, which is 0.5 second. Systole is 0.3 second. This 0.1 is atrial systole, which I mentioned here. Atrial systole, that is, just concentrate. You all know cardiac cycle definition is the cycle of events that is occurring in the heart from one beat to the next same beat. Otherwise, if heart contracts, from that contraction to next time when heart contracts, all those events is called as cardiac cycle. So if I start from here until it comes back to here is cardiac cycle. Otherwise, from one beat to the next beat, which obviously then cardiac cycle should include both systole as well as diastole. Even I can tell it as in atria. So atrial systole, atrial diastole. Atrial systole is 0.1 second, which I am mentioning here. Atrial diastole is 0.7 second. Now I am going to explain about ventricle. Any chamber you can take, but I want to concentrate on left ventricle especially. Yeah, atria is contracting, so that is atrial systole phase, 0.1 second. And what I have mentioned here is atrial systole is a part of, this is ventricle. So atrial systole is a part of ventricular diastole. Please remember, atrial systole, the atria is contracting. Obviously when atria contracts, what will ventricle do? Ventricle will be receiving the blood, which is ventricular diastole. So I already told ventricular diastole is 0.5 second. Of that 0.5 second, atrial systole is 0.1 second, you can see here. Ventricular diastole. Ventricular diastole is the phase where the ventricle is going to fill with blood. Just concentrate here. Yeah, this is ventricular diastole. Yeah, the ventricle is getting filled. This and all I will explain, don't worry. This 0.1 second is atrial systole. This atria is contracting. Now another point which I want you to note it down is this atrial systole contribute to 20% of ventricular filling, and 70-80% of ventricular filling is passive. So no contraction of any muscle is needed. but 20% of the ventricular filling which is going to occur is, or otherwise this 0.4 is passive. This 0.1 is active filling and this 0.1 is atrial systole. That's what I want to explain. Now concentrate this diagram, concentrate this alone. Yeah, this is ECG. We all know that P wave, Q, R, S, T wave. Yeah, the reason for P wave. Yeah, P wave is due to atrial depolarization. Note it down. And we all know electrical events occur before the mechanical events. Otherwise, because of that electrical event only, mechanical event is going to occur. And cardiac cycle includes both electrical as well as mechanical events. Now just see here. Yeah, this P wave is atrial depolarization, which is electrical event. Now what will be the mechanical event because of this atrial depolarization? Atrial systole, that's what. So atrial depolarization occurs in atrial systole and atria contracts. Yeah, atria contracts, atrial depolarization occurs. As the atria contracts, ventricular volume is filled. Just concentrate atrial systole. So during atrial systole or atrial depolarization, P wave is followed by atrial contraction, which is atrial systole. As the atria contracts, ventricle is filling. See here, the ventricular volume. This is left ventricular volume. You can see the slight increase ventricular volume, and this increase in ventricular volume is active. Note it down. This is active. This increase in ventricular volume is active because active filling. That's what. And the MCQ is how much percentage of ventricular filling is due to atrial systole? It is 20%. Remaining 80% will be coming here. You can see here. This is also ventricular filling, which I will be discussing later in the ventricular diastole. Now another thing, yeah, in atrial systole I explained about P wave. Yeah, now we will go to next. So atrial systole is over. Atrial systole is over. Now what happens? Ventricle is filled with almost 120 ml, which is called as left ventricular. Yeah, diastole is going to end. Left ventricular end diastolic volume. Just I want you to concentrate. So 120 ml is what? How much the blood ventricles is receiving. So I am concentrating on left ventricle. So when left ventricle receives 120 ml, and this 120 ml is end diastolic volume, this point. So at this point there is 120 ml filled, which is because of all this filling, which is a diastole, and atrial systole, which is also diastole of ventricle. And I have explained only the first, this is first event. So atrial systole. Now what happens? Second step. Yeah, now at the end of this 120 ml is filled. 120 ml in ventricle. So diastole is over. So note it down. Atrial systole is the last part of ventricular diastole. The ventricle is filled. Now what happens? This ventricle has to contract. So next step is ventricle should contract. So the left ventricle, which has now received 120 ml at the end of the diastole, has to contract so that the ventricle does its function. What is the function of left ventricle? It has to pump the blood into the aorta. So this is the aorta, no doubt in that. So this is the aorta. Left ventricle has to pump the blood into the aorta. The 120 ml which it has received, it will pump 70 ml. That's we call it a stroke volume. So all those things you know. Yeah, now what happens? When this ventricle contracts, here there is a valve, AB valve. Being left side, this is mitral. So now what happens? When the ventricle contracts, this mitral valve closes. That's what I want you to note down. The ventricle starts contracting, mitral valve closes or AB valve closes. So as the mitral valve closes, so this is closed, this aortic valve is already closed. At the starting of this atrial systole 0.1 second, this aortic valve is already closed. I will again mark it here. As the ventricle contracts, I have to send the ventricle blood into the aorta, but this aortic valve is already closed. So imagine rough diagram. So the aortic valve is closed already. So the left ventricle starts contracting and aortic valve is already closed. But this mitral valve has to close. Otherwise what will happen? The ventricle will start sending the blood into backflow into the atrium. But left ventricle has to send the blood into the aorta. So what happens? This will close. So mitral valve closes. Note it down, AV valve. So mitral valve closes. Now see here, already aortic valve is closed. And now to prevent the backflow, mitral valve is also closed. Now just concentrate. We are in ventricular systole phase, starting phase. 120 ml is there, but aortic valve is already closed. Mitral valve is just now closed to prevent backflow. Now this is called isovolumetric contraction phase. Isovolumetric contraction phase. Why contraction phase? It is systole. Why isovolumetric? Both the valves are closed. So even the ventricle, left ventricle is contracting, blood cannot go into the atria or cannot go into the aorta. All the valves are closed. So this phase is IVC. Just to concentrate. IVC. Just to see here. So isovolumetric contraction phase. What happens to the ventricular volume? Remains the same. You can see here. During the atrial systole, the ventricle may be from 100 or some ml to came to 120 ml. Yeah, just to concentrate. Isovolumetric contraction phase, which is a part of systole. No doubt in that. Systole duration is 0.3 seconds. So isovolumetric contraction phase is a part of systole. Now what happens during this isovolumetric contraction phase? Yeah, iso means same. The volume remains same. Ventricle is contracting. Both the valves are closed. What will happen? Just imagine. Ventricle is contracting. This is closed. This is closed. What will happen inside? The blood has to go out. Yes, the pressure starts increasing. There is increase in ventricular pressure. So this is the second event. Now what happens? Increase in ventricular pressure. You can just see again. Now concentrate on this. I have marked left ventricular pressure. Now see here. LVP is left ventricular pressure. Now just concentrate in isovolumetric contraction, where the volume remains same. What happens to the pressure? See here. It is increasing, almost going up to 80. Yeah, 80. So the left ventricular pressure increases to 80 as the ventricle contracts. Now during this ventricular systole, what will happen to the aortic pressure? The pressure in the aorta. Yeah, aortic pressure is also increased. This AP is aortic pressure. Now see here, and this aortic pressure is also coming to around 80. As the ventricular pressure increases, what happens? As the ventricular increase in ventricular pressure increases, there is opening of semilunar valve or aortic valve here. So note it down. So there is opening of aortic valve. Now what happens? Yes, aortic valve opens. Initially it was closed. Why aortic valve opening? Yeah, the ventricular pressure is increasing. See here. The ventricular pressure increases. Once the ventricular pressure comes more than the aortic pressure. That's what I want. Aortic pressure, see here. Yeah, even though aortic pressure is around 80, but ventricular pressure is going more than 80. It is going up to 120. Just concentrate. So the ventricular pressure is more. Here what happens? There is opening of aortic valve. Space is very less. Aortic valve open, which is semilunar valve. And here I forgot to mention here. Here what happens? AV valve close. At the end of atrial systole, ventricle starts contracting. Isovolumetric contraction phase has to begin. But before ventricle contracts, I want to prevent the backflow. So the AV valve is closed. See here, AV valve is closed. Now what happens? In this phase, all the valves are closed. That's why next stage is isovolumetric contraction phase. Now pause the video and tell. Closure of AV valves causes what sound? First start sound. Again see the phonocardiogram. Yeah, first start sound. Just concentrate. S1. S1 is first start sound. S1 is produced due to closure of AV valves. So I am comparing this, all these cardiac events with the Wigger's diagram, and I am making it simple. Yeah, now let us enter into now the topic. What I am discussing is now AV valves, now aortic valve open. So aortic, I have to put a dot. Yeah, so aortic valve opens. Why aortic valve opened? The pressure in the ventricle is increasing. Why the pressure in the ventricle is increasing? The ventricle is already with 120 ml and the ventricle is contracted against the closed chamber. Ventricle is contracting. So as the ventricle pressure increases more than aortic pressure, ventricle pressure is increasing, which causes opening of the aortic valve. Now what will happen? Yeah, ejection. So the blood will be ejected from the ventricle into the aorta. So that is divided into rapid ejection, slow ejection. And mostly 70% of blood is ejected through rapid ejection, 30% of blood is ejected through slow ejection phase, and both these comes under ejection phase, which can be third. We will write here. So isovolumetric contraction is over, maybe rapid ejection, slow ejection. Yeah, ejection, ventricle is ejecting the blood. Now what will happen to the ventricular volume? Yeah, from 120 ml it starts decreasing, you can see here. So this is rapidly decreasing, see the curve. So you need not make up the Wigger's diagram, just based upon these events you can correlate. So now see here, from 120 ml it starts decreasing. This is rapid ejection. Slow ejection, the curve is not as such rapid, then it again goes up to here. We have finished, and we all know this 0.1 to 0.4 is 0.3 second, which is ventricular systole. So ventricular systole includes isovolumetric contraction phase, rapid ejection phase, slow ejection phase. Yeah, during ejection phase ventricular volume is decreasing. Now you tell, during ejection phase, yeah, during isovolumetric contraction phase ventricular pressure increases. Again you concentrate on the ventricular pressure. LVP is left ventricular pressure, just concentrate the red color. Yeah, during isovolumetric contraction phase ventricular pressure starts increasing. This is the point where ventricular pressure overcame the aortic pressure, more than 80. Yeah, that's why aortic valve opened. Now see here, even though the volume is becoming less, but the pressure is there, which is causing the blood to go out of the ventricle. So the ventricular pressure increases, and at 1 phase, this is a very important point. Please remember in this video what I am going to explain now, just concentrate here. As the ventricular pressure increases, and because of that increase in pressure, and aortic valve has opened here, as aortic valve opened, ventricle is ejecting the blood, the volume is decreasing. Now concentrate this. Now here what happens, just you pause the video and tell me, just concentrate here. Yeah, which pressure is more, ventricular pressure or aortic pressure? You just tell me. Red color is ventricular pressure, black color is aortic pressure. Yes. Now what happened, the ventricular pressure starts declining, see here. Yeah, from the 120 ml the blood starts moving, see here, around 70 ml it is coming. So as the blood goes ejected, the volume of the ventricle is also decreasing. As the ventricle function is happening, its pressure decreases. At one stage what happens, aortic pressure is more than the ventricular pressure. Note it down. So at this time, yeah, after this rapid ejection, slow ejection, what happens, aortic pressure becomes greater than left ventricular pressure. Now what happens, this pressure is more than this pressure. As the aortic pressure is more, yes, again what happens, because of this aortic valve closes. So I have to mention here down. So here aortic valve is opened to start the ejection phase. Now the aortic valve is closed to finish the ejection phase. Simple. So systole is getting over here. So this is systole. So systole includes isovolumetric contraction phase, rapid ejection phase, even above I can write, no problem, rapid ejection phase, reduced ejection phase. Yeah. Now both the valves are closed, but this is end of the systole. So all the blood is coming out of the ventricle, but again you have to note it down, out of 120 ml, you see here, out of 120 ml, how much ml will be going, stroke volume? Yeah, approximately 70 to 80 ml. And again you can see in the diagram clearly it is mentioned, around 40 to 50 ml is there. So from 120 ml, only 70 to 80 ml has gone. This is called left ventricular end systolic volume after systole. So after systole, how much is remaining? Around 40 to 50 ml. At the end of diastole, how much blood was filled? 120 ml. So this has also been clearly shown in this diagram, left ventricular end systolic volume. Now concentrate. Both these valves are closed. And what is this phase? Ventricle has sent its blood. So now we are entering into, yeah, AV valve is closed. Now this is called IVR. Maybe I can mark it as fourth. isovolumetric relaxation phase. Just concentrate. Now I have entered into this phase. Yeah, this phase, isovolumetric relaxation phase. Again, I can mark it here in red color. Isovolumetric, again I will mark it here. Isovolumetric relaxation phase, which is the starting of diastole, 0.5 second relaxation. Now, why it is isovolume? Both valves are closed, so blood cannot come in, blood cannot go out. Why it is relaxation phase? Yeah, systole is over. Next, the ventricle is relaxed. As the 70 to 80 ml has gone out, now the ventricle is in relaxed, and the ventricular pressure now you concentrate. Ventricular pressure, just see here, just concentrate the left ventricular pressure. Yeah, it starts with 0. As the isovolumetric contraction phase starts, the ventricular pressure is increasing. One stage, the ventricular pressure is more than the aortic pressure. So what happens? Yeah, see here, this red color is crossing this black color. So the aortic valve opens and the blood is coming out, so the volume is decreasing. Even then the pressure is slightly increasing, and once the required 80 ml is gone out of the ventricle, the pressure drops. Almost it comes back. So the pressure is almost coming back to 0, ventricular pressure. So the ventricular pressure is decreasing during the isovolumetric relaxation phase. So during isovolumetric relaxation phase, what happens to the ventricular volume? Remains the same, isovolume. During isovolumetric relaxation phase, what happens to the ventricular pressure? Decreases. Now what happens? Yeah, during isovolumetric relaxation phase, there is decrease in ventricular pressure, no change in volume, that I am not going to mention. Now what happens? Yeah, now here the pressure is decreased. We all know blood flows from high pressure to low pressure. Now what happens? The blood which is already filled in the left atrium wants to come inside. So what will happen? Yes, this will open. Now because of this decrease in ventricular pressure, there is opening of AV valve, and here it is mitral valve, because I am discussing about left side. So opening of AV valve occurs. So I have to mark. So what happens? AV valve opens. AV valve open. So AV valve opens at the end of isovolumetric relaxation phase. See here, AV valve is opening. I have already marked. AV valve opens. Now what happens? Blood from the, so pressure in the atria is more. That's why that pressure is opening the AV valve. What will happen? Yes, filling. So this is rapid ventricular filling, slow ventricular filling. Yeah, you can see here. As the ventricle is filling, rapid ventricular filling is one phase. In fact, I have to write it here. Because of this opening of AV valve, rapid ventricular filling, slow ventricular filling, and again ventricular volume increases. See here, rapid ventricular filling, what happens to the ventricular volume? From 50, it is again going back towards 120. So this is rapid and this is slow. So rapid ventricular filling, slow ventricular filling, and both are passive. Because at the starting of this video itself I mentioned atrial systole causes active filling. 80% of ventricular filling is passive, which is because of this rapid ventricular filling and slow ventricular filling. So rapid, this RVF is rapid ventricular filling, slow ventricular filling, which is 80% volume. And again I can finish here with atrial systole. So from the sixth phase, it is again going, so rapid ventricular filling, slow ventricular filling. From here, instead of continuing here, I am coming back here. So this is diastole, this is diastole. From here, just you have to concentrate here. Yeah, this is also diastole. I told you this is active. And again, what will happen to the ventricular volume? Increases. And we are finishing with 120. So I have summarized all the events in the cardiac cycle and tried to link these cardiac events with this Wigger's diagram. Yeah, it will be little bit difficult. You can slowly revisit the video and watch it again so that you can understand whatever I spoke. Again, I have to repeat whatever I told from the beginning. So it is very, very easy. Cardiac cycle is divided into ventricular systole, ventricular diastole, ventricular systole is 0.3 second, ventricular diastole is 0.5 second, total duration is 0.8 second. Atrial systole 0.1, atrial diastole 0.7, that is also right. Here I am explaining about ventricle. So I started with, first step I started here is atrial systole, AS, atrial systole, which is a part of ventricular diastole 0.1 second. So total diastole 0.5 second I told. Out of that 0.5 second, 0.1 second is atrial systole. Now concentrate another. This is left atrial pressure. Left atrial pressure. What I am telling atrial systole is left atrial systole. See here, atrial systole. When atria is contracting, what will happen to the atrial pressure? It increases. This is A, positive wave. So I am now telling about left atrial pressure, which has 3 positive waves, 2 negative waves. This is A wave is due to atrial systole, very easy. Now C wave is positive, just concentrate. C wave is occurring in isovolumetric contraction phase. What happens during isovolumetric contraction phase? Just concentrate. Both the valves are closed, ventricle contracts, there is increase in pressure. In isovolumetric contraction phase, there is increase in pressure. Because of this increase in pressure, there is bulge of, I have no space here, bulge of AV valve. Just concentrate, because this ventricle contracts, but all the valves are closed. What happens? The AV ring is bulging, and this push of the AV ring increases like this. Without opening, like this it may bulge. This bulge of the AV ring causes increase in left atrial pressure. That is causing C wave. Just see here, A wave, C wave. Now just concentrate here, V wave. V wave is usually occurring during the isovolumetric relaxation phase. This V wave is also due to atrial filling, a positive wave. So A wave in left atrial pressure is due to atrial contraction. C wave is due to bulging of AV ring because of ventricular contraction during isovolumetric contraction phase. V wave is due to atrial filling when the ventricle is closed chamber and relaxing. I forgot the heart sounds, again no problem. I have to explain each and every diagram separately. I try to coordinate. S1, we all know S1 heart sound, first heart sound is due to closure of AV valves. Exactly, you can see I have drawn the first heart sound here where the AV valve closes. Because of the closure of AV valve only IVC starts, isovolumetric contraction phase, first heart sound. Second heart sound is due to closure of semilunar valves, aortic valve. Just to concentrate. Aortic valve is closed. See the second heart sound. So first heart sound is initiating the beginning of isovolumetric contraction phase. Second heart sound is initiating the beginning of isovolumetric relaxation phase, because second heart sound is due to closure of aortic valve. First heart sound is due to the closure of AV valve. S3. So S3, third heart sound is due to rapid ventricular filling, and you can see ventricular is filling and volume is increasing. So third heart sound occurs in diastole. Diastole means what? Ventricle is filling. So you can write. Fourth heart sound is due to what? Atrial systole. You can see here, AS, atrial systole, fourth heart sound. Very simple. So even the heart sounds we are getting in this diagram. S1 is due to closure of AV valve. In this diagram it is mitral. Second heart sound is due to closure of semilunar valve. In this it is aortic valve. Third heart sound is due to rapid ventricular filling. I have already marked. Fourth heart sound is due to atrial systole. Very clear. So heart sounds are also coming in this diagram. Let us go to ECG. So ECG, we all know P wave is due to atrial depolarization. Just to concentrate here, atrial depolarization, because of that atrial systole is occurring. Electrical event is first, mechanical event is next. Our mechanical events are followed by electrical events. Because of this atrial depolarization, atrial systole occurs. QRS is ventricular depolarization, and QRS you can see is followed by ventricular systole. Very simple. T wave is ventricular repolarization. T wave is here, ventricular repolarization, and this electrical event is followed by the mechanical event, which is passive ventricular filling or diastole. Ventricular repolarization is followed by ventricular filling. Ventricular depolarization is followed by ventricular systole. Atrial depolarization is followed by atrial systole. Almost it correlates. We can summarize. Now how the question in university they will ask is define cardiac cycle, which I already told. It's a sequence of events occurring from 1 heartbeat to the next odd bit. If you want to be specific, from one bit to the next same bit. So the cardiac cycle will include one systole, one diastole. Ventricular systole duration is 0.8 seconds. Ventricular systole is 0.3. Ventricular diastole is 0.5. Previous video is very clear. The events, here I am comparing the events with this Wigger's diagram. Simple. Because this diagram people get confused. For example, in the start of the video when you saw this, it was all confusing. What is A, C, V, what is this, like that. Now it is almost very clear. So I started with atrial systole. I am ending the cycle here. Anything you can compare. If you want ventricular pressure changes also, you can draw correctly. If you want ventricular aortic pressure, for example, you take aortic pressure, but as the ventricular pressure goes more, the aortic valve opens, then you can see here at around, the aortic pressure almost ends at 80, you can see here, yes. So approximately the aortic pressure is coming here to 80. So like that you can easily mark it down. So it is a little bit very exhaustive video. It may be confusing, but we have to try to make these events into this. Don't worry, the question will be all these events you may have to write, including the timing of the event, and they will ask explain about the ventricular volume changes, or they may ask explain about the ECG, or they may ask explain about the ventricular pressure changes, or they must explain about the ventricular pressure changes, which I made it as much simple as possible. This green color is phonocardiogram. So I hope this video was very useful for you. So whomever you feel the cardiac cycle will be confusing, please forward this video to our students community, both medical as well as dental as well as paramedical, so that it will be useful for them. Okay, if you think this video was useful for you and it has clarified your doubts, comment on the comment section so that it will be helpful for the upcoming videos. You can give your feedback also. If you have not subscribed to our channel, subscribe to our channel, Dr. Sen Physiology, so that you will be getting notification for the upcoming videos also. Thank you. We will meet in next video on another interesting topic.